Hey, physics fans, welcome back. This is Physics 12. We're working on forces, and I've applied force of friction, and now we're going to start talking about how the normal force cannot always be the weight that it was in Physics 11. So let's just play with it, take a look at it. Let's do a Physics 11 question first so we understand what we're talking about when we change it. So this is on page 5 of your handout. You pull a 2-kilogram block with a force of 20 newtons. The block sits on the surface of a coefficient of friction of 0.3. Determine its weight. So, free body diagram, we have it sitting on a surface, so there's a normal force, there's a force of gravity, you got the force of pull, the applied force, and there's a frictional force. Okay, and if it is going to move, it's going to move that way. Acceleration will be that direction. There's my free body diagram. So determine the weight. The weight of an object is equal to mg. 2 times 9.8, 19.6 newtons. B, the normal force. Now, the upward force and the downward force have to balance because the motion is in this direction. Everything that's not in the direction of the motion, which is up and down, have to add to zero. So that force and that force have to be equal in magnitude but opposite in direction. So B, we could go all wild here and go that the sum of the forces in the y direction have to equal F net, which equals ma, which has to equal 0, because a is 0. And if that's the case, then normal minus the force of gravity has to equal 0. So that means the normal has to equal the force of gravity. So the normal is going to equal 19.6 newtons. So I just went kind of crazy here and went down why the normal force is exactly its weight because of this. So C, the force of friction. C, the force of friction formula is mu n, and the mu is 0.3, and the n is 19.6. So let's 0.3 times 19.6 will be 5.88. And the direction of that will be opposing motion. That's what friction does. Now, what's the net force? D, the sum of the forces is equal to the net force. And we don't have to worry about the x direction because that's the direction the net force has to be because the motion is in the direction of the net force. So by looking at this, it's going to be F pull subtract force of friction. Which equals 20 newtons, subtract 5.88 newtons. So that's what F net is. So F net is equal to 14.12 newtons. And if I had to give a direction, I'd say right here. Why not? Now E, what's the acceleration? Well, F net equals ma, and this is going to be 14.12 newtons, and that has to equal the mass, which is 2 kilograms, times a. So the acceleration is going to be 7.06 meters per second squared to the right. Okay, that's how you do the Physics 11 one. Now let's just change it a bit. There's a bit more room, maybe not. Now you're pushing a 2 kilogram block with a force of 20 newtons, 30 degrees below the horizontal. So the downward component is 10 and 17.32. So let's just draw our free body diagram. There's still a normal force sitting on a surface, and there's a force of gravity. And if we're going to be pushing in this general direction to the right, there has to be a frictional force this way. And the frictional force is perpendicular to the normal force, always. And now you're pushing down. So you're pushing this way, but we always draw our arrows as a pull. That means and that's our F push in that direction. There's my free body diagram. Please don't put components into it. Now, let's draw it in components down here. Let's just, so we have normal, force of gravity, force of friction, and we're told the components. Although we could figure them out, right? If this is 30 degrees and this is 20, we could, that this is going to be 20 sine 30, which is 10, and this is going to be 20 cosine 30, which is 10 root 3, which is 17.32. Just, I gave them to you already. So let's just try the components in there. Actually, I'll do the components in a different color. There's FP in the X, and I'll write down the number now, 17.32. And there's a downward component. So I'll pull it over here. And that is going to be F pull in the Y, and that's 10. I'm going to go back, I'm going to change it over to blue, and that the force of gravity hasn't changed. It doesn't change. The force of gravity is still going to be the 19.6 newtons. Okay, so that is still going to stay the same. So A is the force of gravity, which is equal to mg, is still going to be a 2 kilogram block accelerating at gravitational field strength of 9.8. That's 19.6 newtons. So A doesn't change. B is going to change, the normal force. Because as I did up above, that you can take a look in the notes that you've taken down, the sum of the forces in the Y have to equal 0. That means the force of the pull in the Y plus the force of gravity has to equal the normal force. Why? Because, now let's just move this down so you understand it. How did I do that? Or if you understand it, great. That the forces down has to equal the forces up. So the down forces, 10 and 19.6, that equals that. So this is 10, and this is 19.6. is the normal, so the normal is going to equal 29.6. 10 more newtons than last time. And that's B. Now C, the force of friction. Force of friction is equal to mu n, which is 0.3 times the normal force of 29.6. Last time it was 5.88. Now it's going to be a little bit more. 0.3 times 29.6. And this will be 8.88. Oh, there's one in, yeah, 8.88. And then the net force, D, this is going to even change quite a bit too. Let's go back to red. The sum of the forces in the X has to equal F net, which equals MA. So that means the force of push in the X minus the force of friction is equal to the F net. And the force of push in the X is only 17.32, not the 20 that it was last time, minus the force of friction, which is higher, 8.88 newtons. That's F net. So our new F net is going to be different. And that is going to be 10 root 3, 17.32, whoa, 17.32 minus 8.88, and it's 8.44. So the last net force, I can't even remember what it was. It was 14, now it's only 8. So changing the angle downwards to 30 from 20, and from horizontal to now below the horizontal, changed it significantly. And let's block that off. And now we'll do the acceleration. F net equals MA, and the net force is 8.44, and the mass is still 2 kilograms, and this is times the acceleration. So the acceleration is going to be 8 divided by 8.44. 8.44 divided by 2, sorry. And that's going to be 4.22 meters per second squared. And again, that would be to the right if we were going to worry about in the direction of the push. And that's E. Yay! That's how you do it. Now, this is increasing the normal force because we were pushing down. What happens if we actually pulled up? Then this 10 would be up. And if that 10 is up instead of down, then the normal force is going to be less, because it'll be normal plus 10 up is equal to the force of gravity, because this arrow would be up. So normal plus 10 up, so the normal would be only 9.6, not 29.6, and not like last time 19.6. So the friction would be a lot less. My guess about 2.88. Anyhow, thank you very much for paying attention. Now try out question number 3. And see if you can get the answers. Right there. And then there's another example. Try it out, see if you can get all those answers from that picture, what's going to happen, and that's the answer. See if you understand the steps now. See if you can do it just from here to get what is the acceleration of that. So there's 2 more questions. There's the answers for the one above and that. Thank you very much. Enjoy. Subscribe, like, comment, and I'll say hi to my class. And enjoy your day. Thank you.